Very interesting shade that I will write over here. Then the PR C sine phi is equal to minus JK rho 0 C 2 pi AB U0 exponential JKR over R. Then I have two terms that is related with the geometry of the scatter. Then I have sine KB over 2 Huh? Okay. Sine phi cosine theta. Are you in Korean? Okay, see, let me see. Okay. English book is correct, is not correct. Korean book is correct. These has to be interchanged. Okay? Now, two things. This is the result derived by Dr. Nam, not by me. We have to acknowledge it. His work. Okay, that's the first thing I want to say. And second, I promise that I will not ask you to derive these things using homo, and also I don't want you to, I will not ask you to memorize all this formula, right? But at least we have to know the physical meaning. First, it has this term. In other words, the radiation of sound is somewhat related with the radiation of breathing sphere or decay, and the phase in space is fluctuating like a JKR. Okay, but in this case, the two-dimensional case, the phase is fluctuating JKR, but the magnitude is reducing square root to 1 over r instead of 1 over r, because to satisfy the conservation of energy in 2D, right? The spreading is occurred in surface, okay, right? That is pi r squared, right? But for 2D case, the spreading is occurred only this circle. So that's why we have these two different factors. And the other one is those are proportional to U0. And AB, that is the area, right? So which means that I have a bigger area, I have a more radiation? Of course, because we are handling with the linear acoustics, that certainly shows the linear acoustics. Okay? And where is B in this case? No B over here. Is it true? It should be proportional to B too. Can I see Korean book? Korean book does not also have a B? Huh? No B, right? Okay. It should have a B, right? Huh?
Right.
Where? Oh, in the appendix.
Yeah.
We have a right one. Ah, right. Wow, we found some error again. So, where? Is it proportional to B, right?
Yeah.
Proportional to B. Okay. Wow. Bingo. So, it has to be proportional to B. And this term, how this term look like? It's sort of a sinc function, right? If B getting large and large, it looks like this. If B getting small and small, it looks like this, right? And we'll have some side lobe. Yeah? That means if you have a small slit, what we will see? We have very spiky radiation pattern. It's like we have a small radiator. But if you have a big slit, big, infinitely large, then, in other words, B is very, very large compared with the wavelengths, then it passes like as if there is no obstacle. Right? On the other hand, you're getting small, then it shows very high directivity. Right? And those kind of directivity for 3D case has not only in this direction but also this direction. That is this term. Okay? Right. So actually diffraction problem and scattering problem can be understood the same way as I described over here. The only the difference is that due to geometry we have this kind of behavior. Okay? Right? So that is quite obvious over here. Now? So what if we have this incident wave coming like that? Then the solution says this solution can also be obtained by using the complex variable, complex functions, and use the branch call, and then we can obtain. Again, that was done by not Y.H. Kim but Dr. Nam, and he obtained the solution